Okay, so let's get into the next part of this lesson. So we're going to do some of the same types of examples. We're going to do them with different types of functions here. So directions for this one say if f of x is equal to the square root of x minus 2 and g of x is equal to 1 minus 2x, we're asked to find the given composition and state its domain. All right, so for number one, we're going to do f composed with g of x. For number two, f composed with f of x. So if we want to calculate what f composed with g of x is, that's going to be f of g of x, which is 1 minus 2x, which means we're going to plug 1 minus 2x wherever we see an x in the function f. So that's going to be the square root of 1 minus 2x minus 2, which is going to become the square root of negative 2x minus 1. Okay, so that's our composite function. Now we want to calculate domain. So first domain we want to look at is the domain of the inner function g. So the inner function g is a linear function, thereby making it a polynomial. So the domain of that is going to be the set of x such that x is a real number. Next, we calculate the domain of the composition f composed with g. Okay, so that function there is a square root function. We know the argument of a square root function has to be greater than or equal to 0 for us to get an output. So we're just going to go through and solve this inequality for x. So when I add 1 to both sides, we get negative 2x is greater than or equal to 1. When I divide both sides by negative 2, the inequality symbol reverses. So that domain is going to be the set of x such that x is less than or equal to negative 1/2. So if we want to calculate our domain here, again, we want to look for the overlap, like what those two sets have in common, or like the more restrictive of the two sets. And if you can't tell, like just looking at both sets, you can graph both solutions. So x is a real number is going to look like that. X is less than or equal to negative 1/2 would look like this. So you'd have a closed dot at negative 1/2, and the graph goes to the left. What do both of those solutions have in common? Well, it's going to be all the values that are less than or equal to negative 1/2. So our domain here would be the set of x such that x is less than or equal to negative 1/2. Okay, on to the next part, f composed with f of x, which is f of the square root of x minus 2. So when I plug that in the place of in the place of x in our function f, we're going to get the square root of x minus 2 minus 2. Okay, so that's our composite function. Now we want to calculate domain. So first domain we want to calculate is the domain of the inner function f. So again, that's a square root function. We know the argument x minus 2 has to be greater than or equal to 0, which would make x greater than or equal to 2. Okay, next domain is going to be the domain of f composed with f. All right, so we have to take the argument. Well, really we have two things that we have to worry about. Number one is that this smaller square root, the argument of that has to be greater than or equal to 0. So we know that, again, x has to be greater than or equal to 2. But then also when we look at this bigger argument, that has to be greater than or equal to 0 as well. Okay, so that means that the square root of x minus 2 has to be bigger than or equal to 0. All right, so I can, if I want to solve this inequality for x, I can add 2 to both sides. Then I can square both sides. And then when I add 2 again, we get x is greater than or equal to 6. So really we have like 2 domains here that we have to consider. And when we calculate the domain of f composed with f, like we want the more restrictive domain or like the overlap of those two. So again, like if I were to graph the solutions or graph like the domains of each of those, x is greater than or equal to 2 would look like this. X is greater than or equal to 6 would look like that. What values do those two sets have in common? The values that they have in common are the x values that are greater than or equal to 6. Okay, so that's going to be the domain of f composed with f. And then our domain is the more restrictive of those two, which we said was the set of x such that x is greater than or equal to 6. All right, so that was an interesting one. You guys have probably never worked with something like that before, where you had to consider 2 inequalities simultaneously. Okay, let's move on to the next one. So directions for the next one ask us to find g composed with f of x and state its domain if g of x is 4 over x minus 6 and f of x is rad x minus 7. Okay, so g composed with f, that's g of f of x, which is g of rad x minus 7. Okay, so that means we're going to plug rad x minus 7 wherever we see an x in the function g, which is going to make 4 over rad x minus 7 minus 6. Okay, so that's our composite function. Now, we want to calculate the domain. So first domain we want to calculate is the domain of the inner function f. Again, with f being a square root function, we know the argument x minus 7 has to be greater than or equal to 0, which would make x greater than or equal to 7. All right, so that's going to be the set of x such that x is greater than or equal to 7. Next domain we calculate is the domain of g composed with f, which is this function right here. So if I want to calculate the domain of that composite function, there are 2 things that I have to worry about as far as the domain is concerned. Number 1 is that the argument of the square root function has to be greater than or equal to 0. Okay, which we already showed for that to be the case that x would have to be greater than or equal to 7. The second thing we have to worry about as far as domain is concerned is because this function is rational, our denominator cannot be equal to 0. So I have to go through and solve that equation as well. So when I add 6 to both sides, we get rad x minus 7 can't be equal to 6. I'm going to square both sides. So x minus 7 can't be 36, and x can't be equal to 43. And I have to combine both of those statements to get the domain of g composed with f, which is a set of x such that x is greater than or equal to 7, x can't be equal to 43, and our domain is the more restrictive of those two, which is just the bottom domain. All right, so it's a set of x such that x is greater than or equal to 7, and x can't be equal to 43. All right, so that right there is the domain of that composite function. All right, let's do one more like this, and then we'll get into a different type of example to close the lesson out. All right, so directions for the next one. Say to find f composed with g of x and state its domain if f of x is equal to x squared minus 9 and g of x is equal to rad 9 minus x squared. Okay, so f composed with g of x is going to be f of the square root of 9 minus x squared, which means I'm going to plug the square root of 9 minus x squared in wherever I see an x in the function f. So that's going to become the square root of 9 minus x squared squared minus 9, which is 9 minus x squared minus 9, which is negative x squared. Okay, so that's my composite function. Okay, we want to state the domain now. So first domain we want to calculate is the domain of the inner function g. Well, we know the argument of that inner function, 9 minus x squared, has to be greater than or equal to 0. And here, like, we have a polynomial inequality. To solve that polynomial inequality, we need to factor. So that's the difference of two squares. It's going to factor to 3 plus x times 3 minus x. And if we want to find where that's greater than or equal to 0, we put the two zeros in order on our number line. And then we're going to test our intervals to see on what intervals we are positive and what intervals we are negative. Okay, so if I pick a number smaller than negative 3, let's say I pick negative 4, when I plug into these two factors, 3 plus negative 4 makes the first factor negative. 3 minus negative 4 makes the next factor positive. A negative times a positive is negative. If I pick a value between negative 3 and 3, let's say I pick 0, the first factor, when I plug 0 in the place of x, is positive. The second factor, when I plug 0 in the place of x, is also positive, and a positive times a positive gives us a positive product. Okay, when I pick a value bigger than 3, let's say I pick 4, 3 plus 4 makes the first factor positive, 3 minus 4 makes the next factor negative, and a positive times a negative is negative. So I'm going to write the domain in interval notation for this one. So it's going to be the interval from the closed interval from negative 3 to 3. Next domain we calculate is the domain of the composite function f composed with g. So that function is negative x squared. That's a polynomial function whose domain is all real numbers. And then we want the overlap of those two sets, like the numbers they have in common, or you can think of it as the most restrictive. The most restrictive of those two sets is the closed interval from negative 3 to 3. Right, so that's the domain of that composition. Okay, we'll take a look at the last set of examples in our third and final video for this section.